In this video, I'm going to show you a famous tricky question in the complex numbers. Let x1 and x2 be the roots of the equation x to the 2 minus x plus 1 equals 0. Compute these values, x1 to the power of 2025 plus x2 to the power of 2025, and also we want to find x1 to the power of 2024 plus x2 to the power of 2024. So x1 and x2 are the roots of this equation. And we want to know what is x1 to the power of 2025 and plus x2 to the power of 2025. The first thing that maybe you think about is to find x1 and x2, because simply we can solve this equation. This is a quadratic equation, and we can use the quadratic formula for finding the roots of this equation. This can be an idea for doing this question. Attention that if you want to solve this equation with a factoring method, you will see that you cannot solve this equation, this quadratic equation, with the factoring method, because you cannot find two numbers that their product is 1 and their sum is -1. And this is because the roots of this equation are complex numbers. So we can use the quadratic formula for solving this equation and finding the roots. Let me remind you the quadratic formula. If you remember, for equation ax to the 2 plus bx plus c equals 0, we can find the solutions. We can find the roots from this formula, negative b plus minus radical b to the 2 minus 4ac all over 2a. Now for solving this equation, if we use this formula, x equals negative b. b is -1 here, so negative b is 1 plus minus radical b to the 2 is 1 minus 4 times a is 1 times c. 4 times 1 times 1 is 4, so minus 4 all over 2 times a, which is 2. This equals 1 plus minus radical -3 over 2. As you can see, inside the radical we have a negative number, and this shows that the roots of this equation are not real numbers. The roots are complex numbers. X equals 1 plus minus radical -3 is basically radical 3 times radical -1 all over 2. As you know, in the complex numbers, radical -1 is defined as I. So x equals 1 plus minus radical 3i all over 2. Let me erase these calculations here and this formula from here. Now that we have the roots of this equation, let me also erase these from here. So, based on the calculations that we did here, the roots of this equation are 1 plus radical 3 I over 2, which you can write this as 1/2 plus radical 3 over 2i. And the other root, x2, is 1 minus radical 3 I over 2, which can be written as 1/2 minus radical 3 over 2i. So these are the roots of this equation. But we are not looking for only x1 and x2. We want to raise x1 to the power of 2025. Suppose for a moment that you want to raise this to the power of 2025, and also you want to raise this to the power of 2025, and then you want to add them to each other. So probably this is not a good idea to do this question in this way, because raising these numbers to these powers is not probably a good idea. Although you can do this with writing these roots in the polar form, and then you can raise to these big powers. But there is a better way for doing this tricky question. And in this video, I want to show you that way. So, by calculating the roots of this equation, we can see that it's not really good idea finding the roots and raising to the power. But what is the trick? Let me write down the equation here again. X to the 2 minus x plus 1 equals 0. Let me write down this equation here. X2 minus x plus 1 equals 0. By multiplying both sides of this equation by x plus 1, so we multiply left side and the right side of this equation by x plus 1. If we multiply left side of this equation by x plus 1, we have this. And if we multiply the right side of this equation by x plus 1, because here is 0, 0 times by anything is 0, so the right side is again 0. If we multiply this bracket in this expression, simply you can see that this equals x to the 3 plus 1 equals 0. Many terms, when you multiply this bracket in this bracket, many terms cancel each other, and finally we have x to the 3 plus 1 equals 0. Before I continue my solution, let me tell you the reason behind multiplying this expression in both sides of this equation. The idea behind this is a famous important identity. This identity, a to the 3 plus b to the 3, can be factored in the form of a plus b times by a2 minus ab plus b to the 2. This is a famous identity for a to the 3 plus b to the 3. Sum of cubes can be factored in this form. Based on this identity, please attention, based on this identity, x to the power of 3 plus 1 can be factored in the form of x plus 1, a plus b, attention, a is x and b is 1. So x to the 3 plus 1 to the 3, which is 1, can be factored in the form of x plus 1 times x to the 2 minus a times b is x times 1 is x, b to the 2 is 1. Now look at this and look at this expression. We had this expression originally here. By looking at this, we remembered that this is part of the factored form of this expression. So we decided to multiply this by x plus 1, because when we multiply this by x plus 1, it simplifies and then we have x to the 3 plus 1. This is the idea behind this multiplication. I know it's so tricky and it's really hard to guess this technique, but when you see the technique, you learn it and you can use it for other similar questions. Okay, let's continue. So this was the original equation. We multiplied both sides by x plus 1. We got to this simple equation now. Now look at this. X to the 3 plus 1 is 0. Simply from this equation, simply we can find x to the 3. And x to the 3 equals -1. And this is exactly the thing that we need for doing the question. Let me show you how we use this for finding the value of this expression. Now that we know that, now that we have this relation, we know that the solutions of this equation satisfy this condition. Whatever x is here satisfies this condition. X, the solutions, the roots of this equation satisfy this condition, which means that, let me explain this in detail here. X here is the same x as here, and the roots of this equation, which are x1 and x2, they satisfy this condition. So x1 to the 3 is -1, and x2 to the power of 3 is also -1, because, please pay attention, because x1 and x2 are the roots of this equation. From this equation we got to this equation, but just by multiplying by x plus 1. And attention, we know that x, the solution of this equation, is not -1, is not the solution of this part. The x1 and x2 are not -1, but they are numbers that when we raise them to the power of 3, they equal to -1. So attention, from this relation, we know that x1 to the 3 and also x2 to the 3, the other roots of this equation, are equal to -1. And now we want to use this for finding the value of this expression. So now for finding this, I am going to write x1 to the power of 2025. I am going to write it as x1 to the 3 all to the power of 675. Attention, 3 times 675 is exactly 2025, plus x2 to the 3 all to the power of 675. But attention, x3 or x1 to the 3 and x2 to the 3 is -1. So the bracket is -1. -1 to the power of 675 plus -1 to the 675. -1 to the odd power is -1 plus -1. So the sum is -2. So the sum of these two terms equals -2. And of course, this is better way than raising this to this power and raising this to this power. But what about x1 to the power of 2024 plus x2 to the power of 2024? What about this? For calculating this, the problem that here we have is that 2024 is not like 2025, which is a multiple of 3. 2024 is not a multiple of 3. But simply we can write x1 to 2024 in this form. We write this in the form of x1 to the power of 2022 times by x1 to the power of 2 plus x2 to the power of 2022 times by x2 to the power of 2. Attention, the sum of these two powers is exactly 2024. Now, 2022 is a multiple of 3. We can write 2022 in the form of x1 to the power of 3 all to the power of 674 times x1 to the 2 plus, in the similar way, this is x2 to the 3 to the 674 times x2 to the 2. Remember that x1 to the 3 is -1, so here is -1 to this even power, because this is raised to even power, so all of this is 1. And also here is -1 to the power of 674, and this is also 1. So this equals x1 to the 2 plus x2 to the 2. Again, this is because this is 1 and this is also 1. Now the only thing that here we have to do is that we have to raise basically this complex number to the power of 2 and then raise this complex number to the power of 2 and then add them to each other. This is one way for doing the question. So here you can complete this solution with raising this to the power of 2, then raise this to the power of 2 and add them to each other. But there is again a better way for doing this. x1 to the 2 plus x2 to the 2 can be written as x1 plus x2 all to the 2 minus 2 x1 x2. Let me explain to you the reason behind this. Why this can be written in this form? Because if you pay attention, x1 plus x2 to the power of 2 is x1 plus x2 times x1 plus x2. If you multiply this bracket by this bracket, it would be x1 to the 2 plus x2 to the 2 plus 2x1 x2. Simply you can check this by yourself. When we subtract 2x1 x2, this cancels and this remains. So this is true that this equals to this sum to the 2 minus 2x1 x2. But why this is helpful for us? Please pay attention. How we want to use this to complete our solution. How this help us to find this expression. Please attention. This is a quadratic equation. This here we have sum of the roots. x1 and x2 are the roots of this equation. We know that in a quadratic equation in general, let me remind you this fact here. When we have in general a quadratic equation, let's say ax to the 2 plus bx plus c equals 0. The sum of the roots, let's say x1 and x2 are the roots of this equation. The sum of the roots are always equal to negative b over a. Negative of this number over a. This is sum of the roots. This is a rule that you should know for quadratic equations. And the product of the roots, x1 times x2 equals c over a. C, the constant, over a. If we use this fact for here, then we have, let's see what we have here. From this equation, the sum of the roots x1 plus x2 equals negative b over a. b is negative 1, so negative b is negative of negative 1 is 1 over 1 is 1. So sum of the roots is 1. And you can check this here. If you add these two roots to each other, this cancels with this. 1/2 plus 1/2 is 1. What about the product of the roots? x1 times x2, the product of the roots equals c over 1. c is 1, a is 1, so it's 1 also. So this bracket is 1. x1 times x2 is also 1. So finally this equals, so finally the answer is 1 to the power of 2 minus 2 times 1, which equals negative 1. So this expression here equals negative 1. I hope by watching the solution of this tricky famous question, you have learned many things about complex numbers, solving equations, quadratic equations, sum of the roots of the quadratic equations, product of the roots of quadratic equations, and other things. If you like this video, please subscribe to my channel.